EES, which is pronounced ease, is an acronym for Engineering Equation Solver. So the videos in this section have shown how to generate property plots for real fluids and ideal gases, as well as brines, and also psychrometric charts, which are good for moist air. These property plots by themselves are not particularly useful because you can't use them to read the properties off of those charts with any degree of accuracy. Certainly it's much more accurate to just call the functions in ease and get the properties that way. But the plots become very useful when you use them as a way of visualizing a thermodynamic cycle or process. And the way you do that is by taking calculated property information from an ease model and then overlaying that onto the property plot using the overlay plot command. This process is most easily accomplished by using array variables for the property information at each state. So let's illustrate this by example. Refer back to the video entitled Real Fluid Property Example. And in this video we showed how to use the ease property functions to simulate a very simple refrigeration cycle, which is shown here. And the associated ease code is shown here. You can see that the refrigerant is R134A, and as we work through the cycle, each of the state points in the cycle corresponded to an element in the arrays T, X, S, P, and H, which are shown here. And so this makes it really easily to visualize this cycle on a property plot. So let's build a TS, or temperature entropy diagram for the cycle. So we choose property plot, we'll choose R134A as the refrigerant, and we can select what isobars we want to use. So we're going to select two specific isobars here that correspond to the condensing and evaporating pressures, and we're going to include isenthalpic lines instead of isocores. And here's the property plot then without the states. To put the states onto this property plot, we'll take the overlay plot command here, and we will display the property information for all four states in the refrigeration cycle onto the property plot. And a couple things to note here. One is if you check the add point labels checkbox, then the subscript number of each plotted point will be located right next to its symbol, so you can keep track of what the different symbols, which state they represent on the plot. Also, if we check the automatic update box, then the state points are going to move around as we change things in the model. So if we were to change the low temperature of the refrigeration cycle, you would actually see after the cycle runs, the plot would be updated to represent the new state points. So the completed plot is shown here, and we can add lines to connect the states and arrows and things like that if you want to make it even more attractive. You can do the same thing with other types of property plots. So for example, a psychrometric plot. If you refer to the video entitled An Example Using Psychrometric Properties, that's a video where we built a very simple model of this air handling unit. So the airstream, as it passes through this unit, has three states: the inlet state, the state after the chilled water coil, and then finally the state entering the conditioned space. And so we can overlay these states on a psychrometric chart in order to visualize the operation of this device. So here we'll do the same thing. We create the chart, and once the chart is created, we'll use overlay plot to put the state points onto this chart. And you can see pretty clearly now the initial cooling and then dehumidification process, which gets you to state 2, and then from 2 to 3 is the reheat process, where we add heat but we don't change the water content. So this is one of a series of tutorials meant to describe the operation of the ease software. If you'd like to get more information about ease, obtain the software, or access more of these tutorials, please go to the website fchart.com. These tutorials are excerpted from the book Mastering Ease, which can also be obtained from the FChart website.